Look at that pathetic little subscriber count. Ugh, that's just bad. What's analytics say? Content, sorry. Well, there's already been 2 views of the graphing 6 practice, and I just gave that out today. That had a lot of views, 96. I only have 96 kids. That's kind of impressive. Subscribe. I'm just a poor math teacher / farmer. Come on, subscribe. Let me get some of that YouTube money. That's what I want. Like Mr. Beast money. All right, back onto this. Number 7. 7 was modified from a quiz, and I just forgot to get rid of the multiple choice aspect. It's not multiple choice. Now, somebody can turn this in with the multiple choice answers chosen. It's not multiple choice. Right here's how you do it. You got to show the work. I hate it for you. But it says find f of -4, which means we take a -4 and we plug it in. Put it over g of -4, which means we take a -4 and we plug it in. And then we just crank out the math, right? Take a -4 and you square it, you get 16. Take 16, then add 8, and you get what, 24? Seems legit. -3 times a -4 is -12. -12 minus 5 is -17, and there's my answer, which would probably be written as -24 over 17 because a negative symbol belongs in the numerator or in front. I hope you realize that. Not everybody does, but that's where it belongs. 8's average rate of change, introduced in Basics 1. You've had 24 chances to get this thing figured out. It was introduced in Basics 1. So go back and look at the bonus questions. It was there. Probably as a class, we're probably at around 50% getting this correct, which is way better than the state percentage. That's the goal, be better. But still, it could be better. Anyways, we're going to plug in we got to find f of b, and we got to find f of a. To find f of b, we plug in a 5, because for the gajillionth time, it's a then b. It would be a 5 squared minus twice a 5. No. 5 squared is 25. You take away 10, you get 15. F of a happens when you plug in a 2. 2 squared minus 2 times 2. That's nice. That's 0. So this is 15 minus 0 up top, because f of b minus f of a over 5 minus 2. That's 15 over 3, which is 5. Moving on to number 9, equation of a line. Just feel like doing a call out here. Alan, quit using y equals mx plus b. You keep missing it about half the time. Use y minus y1 equals m times x minus x1. I just called on him because half the time he gets it right, half the time he doesn't. Just use point slope form. That's what it's for. Your slope is y2 minus y1 over x2 minus x1, in case you forgot. In case you also forgot, you can label x1, y1, x2, y2. Although by this point in time, you should have done so many of these. You don't have to, but some kids do. We'd have 8 minus 5 sitting pretty over 5 minus a -2. 8 minus 5 being 3. 5 minus a -2 being 7. Now I'm just going to throw away a point, because I only need one. It's called point slope, not points slope. Y minus a -2 equals 3/7 of x. I just completely screwed that up, didn't I? Y minus 5 equals 3/7 of x minus a -2. I hope you understand how I messed that up. I got my x's and y's backwards. Even I'm still guilty of that. I do it quite often, actually. So I've actually learned to go back and glance and check. Taking away a negative is a positive. Then I invoke the distributive property. Y minus 5 equals 3/7 of x plus 2 times 3 is 6/7. And then I'm going to add 5. That's going to go over here. So y is 3/7 of x plus, I'm going to write this as 5 6/7, because I want you to go back to 4th or 5th grade, whichever grade it's taught, And I want you to think about how they taught you to convert mixed numbers into improper fractions. I hope you understand that 6/7 plus 5 is 5 and 6/7. They taught you this C method. You did 5 times 7 plus 6, which is 41, sitting over the base, or the whole number, of 5. So y is 3/7 x plus 41/5. There's that one. As easy as I know how to make it. I don't know how to make it any easier. Number 10, write a rule for the sequence. So you get to use this thing. Some of y'all making up numbers for n, and I don't know why you're doing that. This is a sub 1, and the difference is what you add or subtract to move from term to term. So I go from -5 to -1, and that should actually be, oh man, we have a mistake here. Okay. I go from -5 to -1 to 3 by adding 4. Let me redo this one. I'm going to go ahead and print off some things. So -5, -1, sorry, +1. This is the sequence I want. I'll reprint these tomorrow. 7. And I'll give you guys new copies that are correct. Okay. This has a difference of 6. This is what I wanted. Just had a typo. So a sub 1 is still -5, but my difference is 6. So the nth term would be the first term, -5, plus n minus 1 times this difference of 6. Distribute, -5 plus 6n minus 6. Combine like terms, and the nth term is 6n minus 11. And this should work. If I plug a 1 into this thing, I'd have 6 times 1, which is 6, minus 11, which is -5. All right, number 11. Given the sequence a sub n is 2n minus 5, find the sum of the 11th through 25th terms. And there's your form. Okay? There's your form. Your n value is 25 minus 11, add 1 back, which is going to be 26 minus 11, which is 15. All right. A sub 1 is the 11th term because it starts on the 11th term. That seems kind of funny, but that's what this means. First term that matters. It's the first term that matters. So we're going to find a sub 11 by taking an 11 and throwing it right at that little formula. Twice an 11 minus a 5, 22 minus 5 is 17. What I'm hoping is by the time we actually get to difficult sequences, you guys understand what a sub 1 is, you understand what a difference is. You're comfortable with this whole a sub n and s sub n notation because it really throws kids off, especially when we do the chapter on sequences and series. It's the worst of all of them. And I'm hoping for better this year. So I introduced it really early. Let's see here. The last term, a sub n, is the 25th term. So a sub 25 is 25, sorry, 2 times 25 minus a 5, which is 45. I'm just going to plug all this stuff that I found right into my little formula. There are 15 things. It's the sum of 15 things. It's 15 over 2 times 17 plus 45. I'm thinking on the next one, I'm actually going to make you figure the sum out. It's about time you actually did it. I've been trying to get you, maybe not this one, but the one after, I've been trying to get you guys comfortable with the formula. I have been trying. But anyway, 17 and 45 makes 62. 55, 62. Half of 62 is 31. 15 times 30 would be, I just had like a brain fart here, 450. And then add another 15, so 465. That should be the sum of 15 things. This one is really disappointing me. This is taught in Algebra 1. I don't know why we're not getting it. I just don't understand. I remember when I taught this lesson, you guys could do it, and it was better than probably 65, 70% of y'all could do it. And then I guess you slept. I don't know. But you've had several chances to figure this out. I personally am going to go after the y's. You can do whatever you want, but I'm going to eliminate the y's. So I'm going to distribute a 3 to all three pieces. I'm going to leave the top equation alone, and I'm going to have 12x minus 6y equals 24. Now, what I saw probably a third of the student body do was screw up subtraction. Happens. Add opposites. I've been showing you adding opposites on long division. Try it here, see if you have better luck. Add opposites, okay? So 3x plus a negative 12x is negative 9x. The y's cancel. Negative 12 and negative 24 sums to be negative 36, and my x value is 4. And I can think of about 8 kids who wrote down either x or y, and then they stopped. I had to take a point off. You didn't finish. I'm going to look at that dude right there. 3 times a 4, because x is 4, minus 6y is negative 12. That's going to be 12 minus 6y is negative 12. And I can think of more than one kid who did this and then screwed up. When you jump equality, your sign changes. You have negative 12 minus 12. So negative 6y is negative 24. And the y value is also 4. So I have my nice little ordered pair. And I know you guys are like, Mr. Milbrath, this is so hard. This is Algebra 1. This question is Algebra 1. 11 is Algebra 1. 10 is Algebra 1. 9 is Algebra 1. 8's not. 7 should be. 6 isn't. 5 isn't. 4 is. 3 is. 2 is. 1 is. Those are all Algebra 1 standards. Pre-algebra, like 6th grade. Geometry, 10th grade. This is actually junior level math. It used to be. Now it's classified as senior level. But so this is like the only thing that's actually above Algebra 2's level. It's just determinants. And oddly enough, it comes back into play next year. Next year it's back in Algebra 2. All right, so that's the main thing. Here come the bonuses. Given f of x is 4x squared minus 3x plus 3, find f of x plus h. So everywhere I see an x, I'm an x plus an h. So that's the initial step. If something is squared, we write it twice. May as well distribute that while I'm here. X plus h times x plus h. If we FOIL like Jesus would, we get x squared plus 2xh plus h squared. And minus 3x minus 3h plus 3. I didn't do anything in there. I know that notation bothers you, but that's foiling. That's Algebra 1. That's distributing. That's algebra. That's 8th grade. Nothing in this is really new, except the whole, oh my God, there's more than one thing in there. Just function notation. If I distribute the 4, I have 4x squared plus 8xh plus 4h squared, and then I just bring all the rest of this stuff along for the ride. Minus 3x minus 3h plus 3. So since I did bonus 1, I'm going to go down and do bonus 2. Bonus 2 is the difference quotient, better known as the instantaneous average rate of change, which is a calculus concept, a pre-calculus concept, and a calculus concept. Morely a calculus concept. I give you 3 points for figuring this out. So take what you did in part 1 and write it down, because that's f of x plus h. Any good calculus teacher makes their calculus kids do like 20 of these, and then they show them the shortcut. Which I'm not teaching calculus, so I'm not ever going to show you the shortcut. Take away the original function. There's 3 things in that original function, so you make sure you wrap, or you will screw up. And it's all sitting pretty over the letter H. Now lots of things cancel. That's one of the points of difference quotient. 4x squareds cancel because we have 4x squared minus 4x squared. We have a negative 3x, take away a negative, so gone, gone. And we have 3, take away 3, gone, gone. Moving all of my life, I have 8xh plus 4h squared minus 3h. And all three pieces are over an h. So I can divide an h from both pieces. 8xh over h is 8x. 4h squared over h is 4h, which I'm going to put at the end. And negative 3h over h is minus 3. There's a reason we do this. This is basically considered junk. It's nothing. It's nothing, okay? I can't even remember the exact wording of it, but it's nothing. I have a little hint there that this one is going to require more simplification than it has in the past because of how the radicals are going to work their way out this time. So the conjugate of 4 take away a root of 3 is 4 plus a root of 3. Now down low, normally we would say Jesus is foil, but he's a pretty smart guy. He's the Son of God. He would only do first and last on the denominator. So the denominator becomes 16 minus 3, which is 13. The numerator is going to be the full-blown FOIL method. That's a 20 plus 5 root 3 plus 4 root 6. And here's where the simplification comes in, plus root 18. Hey, you there? You there? All right, sorry about that. I had an incoming call. This root 18 is 9 times 2, which is 3 root 2. That has to be cleaned up. And I hate it for you, but we have 20 plus 5 root 3 plus 4 root 6 plus 3 root 2. And as ugly as that is, that's considered the pretty form of the original thing, as ugly as it is. And it's hideous. Anyways, there's your basics. Full explanations. Be faster than me.